All right, 6 block, these are the problems that we did not get to in class today. And so hopefully we can educate you so that you can get your homework done tonight. We're supposed to find the cosine of u minus v given all of this information. So how do we kind of process this information? Over here, angle u, they tell us is supposed to be in the second quadrant. So if I drew a picture of angle u, we're kind of over here, there's angle u. Sine is opposite over hypotenuse. So this has to be 5/13. Since we're in the second quadrant and we're dealing with the Pythagorean theorem, we'll call that adjacent side a -12. As far as angle V is concerned, angle V, they tell us, is also in the second quadrant. So we kind of look like there. That's angle V. Cosine, remember, is adjacent over hypotenuse. So this becomes a -3/5. Your hypotenuse always has to be positive. Since we're in the second quadrant, we'll make that adjacent side a -3, and that makes the opposite side a 4. All right, so here's the plan. We're supposed to find the cosine of angle u minus v, and that's going to equal the cosine of u cosine of v plus the sine of angle u and the sine of angle v. We have all of these pieces of information to substitute for. All right, cosine of angle u, if we go back to our triangle over there, is just -12/13. We're equal to that. All right, cosine of v, they gave that to us initially. They said that that was -3/5. Plus, again, we're sine of angle u. We'll go back to the blue angle over there. Sine of u was 5/13. And the sine of angle v, we're going to call that 4/5. So based on those pictures, that's how I got all of these lovely pieces of information. And then I just need to simplify. Multiplying my fractions, I get a 36/65 plus 20/65. And so if I simplify that, I get 56 divided by 65. And that fraction is as simplified as it will get. All right, problem number 4 says write the expression as a sine, cosine, or tangent of an angle. So the question on here is if I look for, think of this as the sine of u cosine of v plus the cosine of u sine of v. What trig identity or trig formula does that look like? I would tell you that this looks like the sine of the sum of two angles. All right, so my two angles are 110 and 180. So I would tell you that this is the sine of 110 degrees plus 80 degrees. And if I simplify that, I would just say it's the sine of 190 degrees. And I believe on your homework tonight, it just says to write it as a simpler problem. And so that's your answer. You don't actually have to evaluate it. All right. Write the following as an algebraic expression. Oh, this is going to be great. Okay. In general, I want you to see that this problem, the arc cosine of x is an angle. We're going to let it be angle u. The arc sine of something is just looking for an angle. So really, I'm looking for the cosine of angle u minus angle v. That's really what that's asking me to do. Okay, so cosine of u minus v is going to be just in general the cosine of u, the cosine of v, plus the sine of u, sine of v. Great. What do those look like? Let's draw some pictures. I'm going to make this red angle turn into blue. All right, what does this angle u look like? So if I'm going to draw myself a picture, it doesn't really tell me what quadrant I'm in, so we'll just kind of go for it with this. We'll take an angle. This is going to be angle u, and it says the cosine is equal to x. So again, cosine is adjacent over hypotenuse, so I'm going to call the adjacent side x, the hypotenuse 1, and this opposite side ends up just being the square root of 1 minus x squared. If I draw angle V, we'll let that be angle V, it's using an arc sine. And so sine is opposite over hypotenuse. So that means that the opposite side is t, the hypotenuse is 1, and I can make this adjacent side then 1 minus t squared. So that now that I've got these triangles set up, I could come back and resubstitute back in. The cosine of u would be, well, just x. The cosine of v is going to be the square root of 1 minus t squared, and it's over 1. And yeah, technically this x is also over 1. All right. The sine of angle u, and keep switching my pens here, would be opposite over hypotenuse. So the square root of 1 minus x squared, my hypotenuse is 1. The sine of angle v is going to be t divided by 1. All we're supposed to do now is simplify, and it's not going to be pretty, but it is what it is. So x times the square root of 1 minus t squared added to t times the square root of 1 minus x squared, I believe is what we're looking for. That's your answer. It's once just an algebraic expression. That's what they've got. All right. Example 6 says verify this identity. All right. What I want you to recognize that this is a difference, right? We're subtracting here. This is a difference of sign. So if I have the sine of u minus v, this is the same as the sine of u times the sine of v. Oh, I lied. Let's not lie. How about the sine of u cosine of v minus the sine of v cosine of u? All right, I'm going to let u equals 3 and v equal x. So this is the sine of 3 pi times the cosine of x minus the sine of x times the cosine of 3 pi. All right, where in the world is 3 pi? 1 pi, 2 pi, 3 pi. So we're over here at the point negative 1, 0. And remember, it goes cosine comma sine on the unit circle. So cosine's negative 1, sine is 0. So this is really 0 times the cosine of x minus the sine of x times negative 1. So this is really 0 plus the sine of x, which is the identity that we were looking for, or the answer to my identity, which was just the sine of x. All right, last problem, and it's a behemoth. It's a solving problem. I'm sure you're so excited. All right, so I'm supposed to find all the solutions on the given interval, which goes from 0 to 2 pi. All right, please recognize that this is the cosine of u plus v, and then I'm subtracting from it the cosine of u minus v. That's delightful. Okay. Right, so I'm supposed to like add all those things in there and kind of expand it. Okay, so cosine of u plus v, if this is u and this is v, typically that would be, let's see, the cosine of u cosine of v minus the sine u sine v. That's this first part. Minus, all right, if I do the difference of cosine, this is going to be the cosine of, again, x is that, u, and then v is going to be pi over 4. So this will be cosine of u, cosine of v, and that'll change to plus sine of u, sine of v. Okay, so if I go through here and kind of substitute all of this in, I'm going to have the cosine of x times the cosine of pi over 4 minus the sine of x sine of pi over 4. That's this first one. Minus the cosine of x cosine of pi over 4 plus the sine of x sine of pi over 4. And we're wondering where that equals 1. All right. When you're doing this, please note that the negative sign here has to get distributed to both things inside my parentheses. And then as a result, sure, so this is the cosine of x, cosine of pi over 4, minus sine x sine pi over 4, minus cosine x cosine of pi over 4, minus sine x sine pi over 4 equals 1. You have two things that are opposites, and they subtract out. So I really have minus 2 of sine x sine pi over 4 equals 1. How much is the sine of pi over 4? It is the square root of 2 over 2. Those 2's divide out, so I really have negative square root of 2 sine of x equals 1. So I want to know, where does the sine of x equal negative 1 over root 2, or negative root 2 over 2? That's what we're really asking. When does sine equal negative root 2 over 2? Well, that's going to be, all students take calculus. That's going to be in the third and fourth quadrants. Those are angles that are 45-degree angles. So in the third quadrant, your 45-degree angle is going to be 5 pi over 4. And then in the fourth quadrant, your 45-degree angle is 7 pi over 4. Okay. These are single angles, so I don't need to worry about doing the plus 2 pi n and then trying to figure out what happens when n equals 0, 1, and 2. That's all you've got. All right, that's our notes. I guess I don't have an extra sheet of what your homework is, but there's your homework. And so good luck, and we'll see you later.